Hi everyone, welcome back to the training and I hope you all are doing good. Let's start without wasting any time. So, so here we have the packet tracer with us, and in the last class we discussed how OSPF works. So basically OSPF works with a mechanism of area, and in order to connect multiple areas together, let's say you have these three areas. Let's name it as area 10 and area 20. So in order to make communication between devices of area 10 with area 20, you have to connect these two areas with the backbone area, which is area 0. So basically, you have to connect these all the areas which are there on the topology with area 0 to make communication between them possible. So in the last class, we discussed about how we can configure three routers together in an area. We took area 0 and we connected them. We used OSPF single area to make communication between them possible. Now we will add another area with area 0 and we'll try to make communication between the devices of that area with area 0 devices. So let's start and begin the practical. First of all, we will create a topology similar like yesterday, and we will create connection between these three routers, and we are going to consider them in area 0. So let's quickly connect them together using OSPF, and after that we will look into how multiple areas can be connected. So this is going to be R1. Then after that we have R2. Then we have R3. We will add some end devices and let's connect them quickly to see if they are able to communicate after configuring OSPF or not. So here we are adding some modules. Here we go. So now we will connect them together with cable and we configure the rest of the configurations. Now we will create another area here and we'll try to make communication between them. So let's take one router, add a switch, and devices. So first of all, we will quickly make area 0 configurations. after that we will look into this, which is area number 1. So let's start with area 0's configuration first. So we are going to configure 192.168.1.0 on router number 1 and 192.168.2.0 on router number 2. Similarly, 168.3.0 on router number 3. And between these routers, we will configure 192.168.4.0 and 5. After that, you have to type conf t or configuration terminal to enter into the configuration mode. Now we will go to interface FA01 and assign it the IP address 192.168.4.1. Add the subnet mask to make the port up. Now we will move to interface FA00 and will assign it the IP address. So the IP for FA00 will be 1.1 and no shutdown. Interface. Now we are going to create the DHCP pool for router number 1. So the network will be 192.168.1.0. Default router IP will be 192.168.1.1. Now let's quickly get to the CLI of R2 and configure the IP addresses. .0/1 will have an IP 192.168.4.2 at no shutdown. Now interface FA00 will be configured with 192.168.2.1. Add the subnet mask, no shutdown to make the port up. Similarly, interface Ethernet 1/0 will have the IP address 192.168.5.1. And here we go. Now let's quickly configure the DHCP pool for this router as well. The network will be 192.168.2.0. Add the subnet mask. So we will say no and enable. A 0/1 IP address 192.168.5.2. Add the subnet mask and no shutdown. Interface FA00 IP address 192.168.3.1. Add the subnet mask. We can exit from the interface mode and configure the DHCP pool. Let's try to get the IP for PCs using DHCP and see if it works or not. Now we are ready with our IP configurations for all of the devices. Now we will move ahead to towards the configuration of OSPF. So I have just renamed the router to R1. Now we will run the command do show IP route to check the directly connected routes. And when we see the list, we can find that 1.0 and 4.0 are the routes which are directly connected to router number 1. Now we will configure the OSPF configuration on the router. So it will go from router OSPF, and if you put a question mark after that, it tells you that you have to add process ID. So we will take any number ranging from 1 to 65, 535. So let's take 10. And after that, you have to add network which you are willing to advertise. So the directly connected network are 1.0. Now, if you again put a question mark, it will tell you to add the wildcard bits. So we yesterday discussed how we can calculate the wildcard mask 0.0.0.255 since the IP is from class C. Now again, if you put a question mark, it will tell you area, and after that it's written that set the OSPF area ID. So you just simply have to tell it about the area. So we are in area 0, right? And we press enter. Now the same command will go for 192.168.4.0, add the wildcard mask and area 0. Here we take an exit. Now let's go to router number 2. Change the name to R2 and have a look at the routing table. Now the directly connected routes are 2.0, 4.0 and 5.0. We will run OSPF 10 and add the networks to that. So network 192.168.2.0, the wildcard mask and area will be 0, right? Similarly, for 4.0, the command will look like something. Network 192.168.4.0. After that, the wildcard mask, which is 0.0.0.255, then area. And we'll go for 5.0. Here we are done with the configuration of router number 2 as well. Now let's move to router number 3. Now the directly connected routes are 192.168.3.0 and 5.0. So we will quickly configure OSPF, and the command will look like 192.168.3.0, wildcard mask and area. Only for 5.0. Now we have successfully configured the routing protocol, and the PCs under these networks shall communicate with each other. So we'll try pinging from one PC to another. And if we try pinging from PC 16 to PC 19, it says failed, but if we retry it, it says successful. So this was the basic configuration of single area communication between devices. And even if you try pinging from any PC to any different PC of different network, so it will go successful. So which means that devices are able to communicate with each other. Now we will understand how we can make devices of area 0 be able to communicate with devices of area 1. And let's just quickly create another area 2, and let's try making communication between all these areas possible. So here we have another area 2. Okay, we have some questions in the chat. Let me quickly answer them before we move ahead. And yes, area 0 have to be the backbone area, and it is always said that area 0 is backbone area, so you cannot change that. So we have command is necessary. Yes, you have to type the wildcard mask command to add the, like, to advertise your network. You have to add the wildcard mask. Even in case of EIGRP also, wildcard masks are used, but when you do subnetting, that's the case. So you can use wildcard mask in EIGRP as well. Let me just quickly give you an example. So if you take one router, go to the CLI, router EIGRP, add the network. We are just doing this as an example and don't take this literally. So there is no such interface connected, but still, if you put a question mark after the network ID, you will see that you to add the EIGRP wildcard bits. So even if you add it or not, it will work. But in case of subnetting, if you are doing subnetting, you have to add the wildcard mask accordingly. It was discussed in the last class. Wildcard masks are basically the inverse of subnet mask, and in order to calculate them, you can use like you can simply subtract them out of 255. You can subtract the subnet mask out of 255 and it will work. So let's now quickly get back to OSPF instead of discussing about wildcard mask. So now we are going to try OSPF between these three areas. So let's add a router here as well, one switch and some end devices. So let's consider this as router number 4 and router number 5. Now we are going to connect them over the cable. Okay. So in order to make them communicate with each other, you have to connect them with area 0, right? And we will connect them with router number 3 like this. Now I want you guys to pay focus here, and I mean pay attention here and be focused. So as we discussed in the yesterday's class, I want you guys to answer this. So let me know, what can we call this router, the router number 3? We discussed this yesterday only. Exactly. So we have the answer already in the chat. ABR, area border router. Since the router is participating in more than one area, we can call it as area border router. Similarly, this router will also be known as area border router. Why? Because this router is also connecting area 1 with area 0, right? And this router as well can be known as area border router. Now, let's take a network of 192.168.6.0 and 192.168.7.0. Now, like we took a network between these two routers, we have to take two networks between these two as well. So we will be taking 192.168 8.0, and similarly here we will take 192.168 9.0. And the IPs can be 1 for this router and 2 for this. Then similarly 9.1 for this and 9.2 for this one, router number 5. So till now we have configured IP addresses on these three routers and we have configured DHCP pool on them. And the topology is clear to all of us. This is the area 1 and this is the area 2. Now, if we look at router number 1, we can say that all of the interfaces of router number 1 are in area 0, right? And for the same reason, we can call it as backbone area. And similarly, if we look at the router number 2, all of the interfaces are in area 0 and we can call it as backbone area. Backbone router, I'm sorry. So backbone area is area 0 and a router with all interfaces in area 0 is known as backbone router. Make sense? Now we are going to configure IP address on these routers, router number 4 and 5, and we'll be configuring DHCP as well. So let's take So I'm not sure, Mohammed, what you are trying to say, but the thing is that we have created a fresh topology. If you are talking about yesterday's class, so maybe there were only one router. Maybe that could be the reason I told you that R3 is the area border router. But I hope this is clear to you now how area border router can be identified. So any router who participates in more than one area can be known as area border router. Now we are going to configure router number 4. Let's change the name to R4. Interface FA00 will have the IP of 192.168.6.1 at the subnet mask and no shutdown. Now interface, okay, FA00 is configured. Now we are left with FA0/1, which is connecting to R3. So we will take the IP address 192.168.8.2, 255.255.255.0. I am taking 8.2 on this router and I will take 8.1 on this router. So here we have the IP address command, then we will say no shutdown and we are done. Now let's take an exit and quickly create a DHCP pool. 6.0. Then we have default router IP. Exit. Now we are going to configure router number 5. Well, conf t, change the name to R5. Okay, after that, you have to configure IP on interface FA00, which will be 192.168.7.1 at the subnet mask and no shutdown. Now interface FA01 IP address 192.168.9.1 at the subnet mask. Okay, we will take again 9.2 for the same reason. Now we are going to add the subnet mask 0, no shutdown. Take an exit and add the DHCP pool. Exit. Go to the interface of router number 3. So enable conf t interface Ethernet 1/0. It will have the IP address 192.168.8.1 at the subnet mask and no shutdown. And if we just look at the port number which is connecting R3 to R5, so it is Ethernet 1/1. So I hope it is visible to you guys. And we will take an exit from 1/0. Enter the interface Ethernet 1/1. Configure the IP address. Shut down, and here we go. We have successfully configured IP address on all of the interfaces. Now let's try to get the IP for end devices. So we have the IP. DHCP is working fine. So let me just remove the device names in order to make this a little clear. So now we are done with the configurations of DHCP and IP addresses. Now I want you guys to pay attention and understand this. So FA01 of this router, which is router number 3, is in area 0, and FA00, which is connecting to the switch, is in area 0, right? Now, in order to make the communication, you have to put Ethernet 1/0 in area 1 and Ethernet 1/1 in area 2. And on the other end, this interface FA01 will be added to area 0 and FA00 will remain in area 1. Am I making sense? Let me know if you guys are finding this difficult to understand. I will repeat myself. Okay. So what's going to happen here is, in order to make the communication, we are going to put these interfaces which are connecting to this area 1 and area 2. We are going to put them in the area 1 and area 2 respectively. So basically, what we are gonna do here is, let me just quickly get to the configuration. So I hope that will make this more clear to you all. Now we have two interface on router number 4, right? And they'll be in area 1. So let's quickly configure the OSPF. Network 192.168.6.0 at the wildcard mask and area 1. Similarly, put the other network which is 8.0 in the area 1. Take an exit. Now go to area 2, router OSPF 10, network 192.168.7.0 at the wildcard mask. Area 2. The same will go for the other network, which is 9.0. I hope it is clear till now. I have just simply placed the interfaces of these routers in their particular areas, right? Now I will put Ethernet 1/0 in area 1 in order to make the communication. So we will go to interface. So we will again go to router OSPF 10 and we will advertise the network 192.168.8.0 at the wildcard mask. We are going to put it into area 1. Now for 9.0, what we will do, okay, we already have the log of adjacency. So we just advertised our network 8.0. Now we will advertise 192.168.9.0 and we are going to put it into area number 2. Press enter. We can exit. Try to ping from this to this. It says failed and then successful. Make sense? Now, if you try pinging even from this PC to this PC, it will go successful. So, like this to this, it says it is successful. So what we have done exactly here is, so we have configured Ethernet 1/0 in area 1 and Ethernet 1/1 in area . So the interface which is connecting a different area is configured to that area only. So basically, since Ethernet 1/0 was connecting R3 to R4 and R4 is in different area, right? So in order to make the communication, you have to put that interface into that area. Is it clear to you all now? Awesome. So now I want you guys to answer that in this case, what will be the ABR? Which router will be ABR? Okay, we have a question R3 FA01 in area 0. Yes, FA01 will stay in area 0. FA00 will also stay in area 0. But Ethernet 1/0 will be in area 1 and Ethernet 1/1 will be in area 2. Okay, we have the answer. R3 is the ABR. And if, as I said before, if this router again connects to some different area, then this also will be considered as ABR. So is it clear to you all now? Yes, okay. So we have question, what is ABR? Okay, so ABR is area border router and a router which participates in more than one area. Now, as we have configured the whole configuration on all of the devices, is it clear to you that which router has participated in more than one area? So the router is R3, which has participated in area 0 and area 1 as well, right? Yes, exactly. So R3 is the area border router. Okay, so LSA type. So okay, Dilkush, we will not look into that much details as of now. These are the packet types and you can consider them as advertisement type. Okay, so basically they advertise their network over such packets. Yeah, sure. So this is a command which you use to check what all configurations are made on a router. So command is show running config. This is the command. And once you press enter, you get all the configuration which you have made on the router. We can see we have created a DHCP pool for this router. And if we go ahead, we keep pressing the enter or just click on the space bar, you will get the further details. So it says that interface FA00 is now like configured with an IP of 192.168.3.1. And if interface FA01 is configured with 5.2. Now interface Ethernet 1/0 is configured with 8.1 and similarly 1/1 is configured with 9.1. Here we have all of our commands for router OSPF, or we can say that we have the details related to OSPF. Yes, in that case, you were exactly right. And Mohammed, I'm sorry if I took you wrong, or maybe I misunderstood your question. But yes, you are right that if a router is participating in area 0, 1, and 2, then we can call it as area border router. So these are some details of configuration which we have made on the router. So you can check this by using the command show running config. You can look at the command which I have run here. So this is the command which you can run to look at the configurations which are made on the router. So now if you want me to type out all the commands, I can do that quickly on the notepad, and so that you don't have to be like, you don't get confused with the areas. Otherwise, if you are good with the commands, you can take your time and try performing this practical. So basically, this circle and square is not something we usually do in real life, but this was just for your basic understanding. So yes, you can put it here if we like literally go into the details. So it will be like participating in this area 0 and area 1 and 2 as well. Okay, I'm writing the commands for router number 3, and rest of them can be done by you, as those commands are some very basic commands, right? Okay, give me a minute to type out them all. So either you can just save the file, or you can run the command write, WRITE, to save the configuration. And we have some more questions here in the chat. Okay, so I see a question which says that can we make communication between area 1 and area 2 directly without area 0? No, that won't be possible. Any communication without area 0 can only be done when there is only single area. So let's say we create another area. Let's say this is the area 7 or 5, and we put some devices in it. So in that case, you can make communication between these devices. But if you try to make communication between two areas without area 0, that won't be possible. Okay. So we have another question, why we are using multiple areas. Okay, so when you create OSPF, when you configure OSPF, there is some packet types which are flooded between them. So if we talk about area 0 specifically, so you can consider them as a message. So some messages are there which are flooded between these devices. And that in order to like, we can say, in order to avoid that flood of messages between devices, we create different areas so that the flood I mean the when you create when you configure OSPF, there are multiple types of messages which are flooded between devices which are in same area. So basically what will happen here is these devices will keep communicating with each other using those particular messages which are flooded, and same will go for area 1. And that's something that's how you can like avoid that flood of messages by creating different areas for number of devices. Jaspal, they will work absolutely fine, and there is no such requirement to create such areas. So the basic practice to do OSPF is there are multiple reasons, right? We just have studied about the fundamentals of RIP. We have discussed the EIGRP fundamentals, and the same goes for OSPF as well. But when you look at them, when you compare them, you will find some differences between them, right? So basically, RIP is used in small organizations where the number of devices are like not more than 16. And when it comes to EIGRP, it can be used in organizations for internal communication. Again, OSPF is something in which you can connect n number of hops. So there is no limit to connect devices when a network is configured with OSPF. So basically, these are the differences according to which a protocol is selected for the communication. Yes, yeah, you have to connect them to area 0 to make the communication possible. So let me quickly get the notepad to write them all. And so we will not talk about passive interface as this might confuse others who are new to this. But I can say that these are used to in those cases which can be like in order to make outgoing or incoming communications, in order to control outgoing or incoming communications. So that's not something related to the topic which we are discussing as of now. That's something advanced, and we will try to avoid that as of now. We can talk about this later. Now I am typing all the configurations for router number 3. So first of all, we will go to enable quantity interface FA01 IP address 192.168.5.2.255.255.255.0. No shutdown. Interface FA00 IP address 192.168.3.1 at the subnet mask, and no shutdown. This Ethernet 1/0 IP address will be 192.168.8.1 at the subnet mask, shutdown. Ethernet 1/0 1. The IP address will be 192.168.9.1. Shutdown. Now, after this, you can configure the IP DHCP pool for the network 192.168.2.0, 3.0, and net mask to default router, and IP will be 192.168.3.1. Take an exit. Now the configuration of OSPF begins, and it will be router OSPF then you have to type network, then the network ID. We have directly connected to us as 5.0, add the wildcard mask and the area. So if we look at 5.0, that's on FA01, right? So FA01 will stay in area 0 only. Network 192.168.3.0 will add this wildcard mask, and this interface is also remain in area 0. Now network 192.168 8.0. Now this interface is a part of area 1, and network 192.168 9.0 will be a part of area 2. Make sense? Take an exit. Now I am also writing the commands for router number 4 and 5 so that it can be easily configured. You go to enable it. T interface FA00, and if we look at interface FA00, it is configured with IP address 192.168.6.1, add the subnet mask and no shutdown. Now interface FA01, IP address 192.168.8.1, add the subnet mask and no shutdown. You can exit. IP DHCP pool A network 192.168.6.0 and the subnet mask. Default router 192.168.6.1. Take an exit. Now for OSPF will look like network 192.168.8.0 0.0.0.255. Okay, so make sure you configure this with 8.2. Since we have used 8.1 on R3, we will take 8.2 here or anything other than 8.1. So now this will remain in area 1, and the other interface, which is 192.168.6.0, that too will remain in area 1. Now take an exit. After 5, we will just copy the commands and make changes into that. So on interface FA00, we have 7.1, and on interface FA01, we have 9.2, then 7.0. Default router will be 7.1, and this will be 7.0 and 9.0. I hope the commands are clear to you all, and now take your time, try this out and let me know once you are done. Oh yeah, so thank you so much for correcting me. This will be area 2. So guys, I hope everyone is done with the practical. Let me know if you have any doubt in this, and in case if you faced any difficulty with any command, you can let me know. Otherwise, we are good to move ahead. Okay. So now we are going to learn about something known as, you can call it as DHCP relay, or we can say DHCP one for all. So basically what we are going to do in that is we will configure DHCP for all of the routers on a single router, and after that we will make some configuration so that PC being from any network can get the IP address from that DHCP server. We are going to look into that after this. Okay, router 4 connected to router 3 in area 0 or area 1. So all the ports of router 4 will be in area 1 and all the ports of router 5 will be in area 2. Clear? Is it clear to you, Pradeep, now? Let me know if you want time. If you are still on the practical and want time, we can wait for you for a few minutes. So this will be the configuration for router number 3. 8.0 will be in area 1 and 9.0 will be configured in area 2. So if we look at 8.0, it is Ethernet 1/0. And if we look at 9.0, it is 1/1. So I hope this is clear to you now. And okay, great. What we are going to do now is, okay, let's quickly create a network of single area and configure them all with area 0 to make the connection possible. So we are going to add some modules. Add some switches with them. And end devices. Make them using a cable. Like this. And okay, so this is going to be a topology. And we'll be configuring area 0 between all of the routers as a routing protocol. OSPF will be configured between them to make communication between devices. So here we go. Okay. Cool. So this is going to be area 0 and we will configure 192.168.1.0 on this this router, and after that similarly 192.168.2.0 on this, 192.168.3.0 on this router, and 192.168.4.0 on this router. And between these two routers, we are going to take IP from class B. Let's take 150.10.10. 10.10.1 and 2 for these two routers, and 150.20.10.1 and 2 for these two. I hope topology is clear to you all. Now in this topology, what we are going to do here is we'll be configuring DHCP only on one router for all of the networks, and we will see how we can make this possible that the PC from a different network can get IP from a server, DHCP server, which is in different network. So we will be looking into that in this practical. And before that, let's quickly get them configured with the IP addresses and the OSPF. So no, enable conft, change the name to R1, and after this, we are good to configure interfaces. Interface FA00 will have the IP address 150.10. The subnet mask, shut down 01 will have the IP 150.40.10.1 and the default subnet mask, shut down. Now interface Ethernet 1/0, IP address will be 192.168.4.1, subnet mask, shut down, can exit. Now we'll go to router number 2, go to CLI, conft interface FA0/0, IP address 150.10.10.2, add the subnet mask, shut down. Now interface Ethernet 1/0, IP address. I hope I am not too fast. You guys are able to understand the commands. Since all of these commands are very basic commands which we have already practiced multiple times, so I'm going a little quick on these commands. Then we will go to interface 0/1, add the IP address 192.168, okay, 150.20.10.1, no shutdown. Exit. Go to router number 3. Enable conft, change the name to R3. Is FA00. The address 150.20.10.2. Shut down interface FA0/1. IP address 150.30.10.1. Take an exit, close the CLI, go to router force CLI. Enable conft, change the name to R4. To interface FA00, IP address 150.30.10.2. Shut down. Now interface FA01, IP will be 150.40.10.2. Shut down. And the last interface Ethernet 1/0, it will be configured with IP address 192.168.3.1. Add the subnet mask, and here we go. Now